Let's now see a string that will work using our pumping lemma for the previous language. Let's restate the previous language. We want to show that this language is not context free. The previous string that we have used did not work for the purposes of the pumping lemma. Let's now try the following string s. So now we show a good choice of a string s that will work for the purposes of the pumping lemma. Let's say s is 0 to the p, 1 to the p, followed by 0 to the p, 1 to the p. The previous string was, in the previous example, 0 to the p, 1, followed by 0 to the p, 1. This time we choose a new string. Let's see if this string satisfies the conditions of our pumping lemma to see if we can use this special string for the pumping lemma. The string should belong to the language. It does if we split the string into two equal halves. The first half, 0 to the p, 1 to the p, is the same as the second half, 0 to the p, 1 to the p. Therefore, the string is in the language, and its length is greater than or equal to p. Its actual length is 4p. So this is also satisfied. This means that for the purposes of pumping lemma, we can use this string s. Let's try to visualize s, what s looks like. It will be partitioned into 5, u, v, x, y, z, p many zeros, followed by p many ones, followed by p many zeros, followed by p many ones. Okay. Again, let's try to construct different cases, all possible cases actually, based on this middle substring vxy. For the first case, case 1, remember that if we can show that for every case we can find some value of I such that uv to the I, xy to the I, z, that new string does not belong to the language L, then we will be done with the proof that the language is not context free. For the first case, consider the scenario where this middle substring vxy only contains one type of a symbol. Vxy contains only one type of a symbol. Again, let's try to visualize. These are our zeros, followed by ones, followed by zeros, followed by ones. We have p for each one. We have p zeros, p ones, p many zeros, p many ones at the end. Vxy contains only one type of a symbol, which means that Vxy can be among the zeros here. So Vxy can be here among the initial zeros. Let's call this case 1.1. Case 1.2, Vxy can be among the ones, 1.2. Case 1.3, Vxy can be among the zeros in the second half, 1.3. 1.4 corresponds to Vxy being somewhere among the ones at the end. We shall only consider in detail this first case because the rest of the cases, 1.2, 1.3, and 1.4, will be very similar. So let's first concentrate on this case 1.1. For this, let's consider the new string as follows. The new string uv to the 0, x, y to the 0, z. What does this new string look like? Since vxy, so 1.1, since vxy belongs to the initial zeros and we are pumping down, basically we are removing v and y parts in our string uvxyz, this means that we will be, since v or y is not epsilon, we are definitely removing some number of zeros in this part. And the new string will look like the following: zeros, ones, zeros, ones. Number of, since we didn't do any change in the remainder of the string, we will have P0s, P1s here, P0s here, followed by P1s here, and the initial zeros in here is definitely now less than P, since Vxy belongs to the initial zeros and V or Y is not epsilon, meaning that V or Y contains some number of zeros, and in the new string we are removing V and Y. Therefore, some number of zeros will be removed in the new string, and it will look like the following. Now, in this new string, let's check the length of uv to the 0, xy to the 0, z. What is length going to be? So length of uv to the 0, xy to the 0, z. The new length, the length of this new string is definitely less than 4p, because the length of the original string is 4p, and we are definitely removing some number of zeros. So it will be less, it will have length less than the length of the original string. Because V or Y is not epsilon, V or Y contains some number of zeros, and we are removing some number of zeros from this original string. And a second thing, we have a lower bound on the length as well. We know that the length should be greater than or equal to 3p. How do we know this? Because by condition 3 of the pumping lemma, the length of the middle substring Vxy together, we know that is definitely less than or equal to p. Okay, and we are removing V and Y. This means that from the original string, we will be removing at most p many symbols. If that's the case, then we will be decreasing the length of the original string by p at the most. Therefore, the length of the new string will be at least 3p. Now, according to this, let's try to visualize where the middle of this string is. Since the length of this new string is at least 3p, let's divide these zeros in here into 2. So let's say this part we have p divided by 2 zeros, and in this part let's say we have p divided by 2 zeros. If this is the case, it should be clear that, so this tells us that the right half of the whole string, of the whole new string, should have at least length 3p divided by 2, and at most length 2p. This tells us that the middle of the new string is somewhere in this range. This is the initial zero, first zero in the second half. This is where the middle of the string lies. Middle of uv to the 0, xy to the 0, z. Since the length of the string is at least 3p and at most 4p, the middle of the new string can be somewhere in this range. If that's the case, then it's easy to see that this new string uv to the 0, xy to the 0, z is not in the language, does not belong to the language. Why? Because there will be, so the left half of the whole string with respect to the new string will be zeros followed by ones followed by some number of zeros, whereas the right half will be only zeros followed by ones. Therefore, we can see that this new string does not belong to the language. We can repeat the same type of analysis for cases 1.2, 1.3, and 1.4 as well. This handles case 1. If Vxy contains only one type of a symbol, we can show that there exists some integer I such that uv to the I, xy to the I, z does not belong to the language. Let's see the second case, case 2. So, case 2, Vxy contains two types of symbols. So, let's try to visualize our string UVXYZ. We have p many zeros followed by p many ones followed by p many zeros followed by p many ones. This case says that VXY contains two types of symbols, meaning that VXY, let's see, VXY can be somewhere here. VXY may belong to somewhere here in this range. Let's call this case 2.1. And VXY may belong to somewhere in this range. This is 2.2. This is where VXY belongs to somewhere in this range. And it could be the case that VXY belongs to somewhere in this range, again containing two types of symbols. Let's call this 2.3. This shows us where, this range shows us where VXY can lie. We will see that it should be visible that these two cases, 2.1 and 2.3, are quite similar. Let's first try to think of in terms of case 2.1. For this scenario, again, let's try to think of our new string uv to the 0, x, y to the 0, z. Let's see how it looks like. A bunch of zeros followed by a bunch of ones followed by a bunch of zeros followed by a bunch of ones. VXY is within this range. Okay, it contains zeros and ones. It's because it contains two types of symbols. Now, if we pump down, or in other words, if we remove the substrings v and y from this whole string, it will look like the following. And in this case, note that if v or y is non-epsilon, it will mean that we will be removing some number of zeros or some number of ones from the first half of the string. And again, it will be the case that the length of this new string will be at least 3p and at most 4p. So again, length of uv0 to the 0, xy to the 0 is greater than or equal to 3p. This is true since, due to condition 3 of our pumping lemma, length of vxy altogether is at most p. And if we are removing that part from the original string, this means that from the original string we are removing at the most p many symbols. And since the original length is 4p, the new length will at least be 3p. And it is less than 4p because we know that due to condition 2, v or y is not epsilon, which means that we will definitely be removing some symbols from the original string, and this means that the length will be less than that of the original string, will be less than 4p. Now again, let's try to see where the middle of this new string lies. So if we have, since we didn't touch anything in here, we'll have p many ones. Let's show the range in here where we have p divided by 2 zeros. So the new, since these are the lower bounds and upper bounds for the length of our new string, the new middle can start here and can end in here again. So this is where this range is the range where the middle of this string uv to the 0, xy to the 0, z lies. Now if this is the case, again we can see that if we consider the string divided into two equal length halves, for the second half, for the right half, we have p many ones. We have p many ones at the end, and at the beginning we have p many zeros. Whereas in the first half of the string we have p zeros followed by p ones followed by some number of zeros. So it's easy to see that then the new string uv to the 0, x, y to the 0, z does not belong to the language, because the right half of the string is some number of zeros followed by some number of ones, whereas in the left half we will have zeros followed by ones followed by zeros, and the right half is not the same as the left half. Let's now consider the second case. Okay, note that the case 2.3 will almost be the same as 2.1, so 2.3 is similar. Therefore, we won't go into details of this subcase 2.3. Let's now consider case 2.2. Since this requires a different attention, we will cover this in a little more detail than 2.3. So again, let's try to visualize uv to the 0 x, y to the 0 z. In this case, we have zeros, ones, zeros, and ones. Now, it will remember that this case 2.2 assumes that vxy belongs to this range. Okay. Now, in the new string uv to the 0 x, y to the 0, let's consider the following case. We definitely know that v over y is not epsilon due to the second condition of pumping lemma. Let's consider the case where v is not equal to epsilon, which means that v contains some number of ones, or v contains some number of ones followed by some number of zeros. Okay? If this is the case, due to this condition, v not being equal to epsilon, let's see what happens. If we are removing in the new string uv to the 0 x, y to the 0 z, we are removing the substring v from the original string. Okay? Since we are removing, so v definitely contains ones, because v is not epsilon, it will contain ones, or it will contain ones followed by zeros. And in the new string, therefore, the number of ones will definitely be less than p, okay, corresponding to this case. V is not epsilon. This means that v must contain some number of ones, and in the new string uv to the 0 x, y to the 0 z, since we are removing v, the number of ones will be less than p. And since vxy belongs to this range in here, this means that in the new string uv to the 0 x, y to the 0 z, we are not making any modification on the number of ones at the end of the string. So this is still equal to p. This implies that in this case, uv to the 0 x, y to the 0 z will not belong to the language, because if we cut the string into two halves, in the right half we will have p many ones, whereas in the left half we will have less than p many ones. Okay. The second scenario is going to be similar. V is epsilon, and if v is epsilon, remember that due to condition 2 of pumping lemma, v over y is not epsilon. If v is epsilon, then y must be non-epsilon. Y is not epsilon. Y contains some number of strings, and we can apply the same arguments. If this is the case, let's draw the string in this case. We will have zeros followed by ones, followed by zeros, followed by ones. In such a scenario, we will see that since vxy belongs to here and y is not epsilon, y will definitely contain some number of zeros. It may contain zeros followed by preceded by ones, or it may only contain zeros. But in any case, y contains some number of zeros in here. If this is the case, after pumping down v and y in the new string uvxyz, we will have basically less than p zeros in this part, in the second half of the string. And since vxy belongs to this range, we didn't do any modification on the number of zeros at the beginning of the string. So this will still be equal to p, which implies that if we consider now the new middle of the string will be somewhere here, on the left half of the string we will have exactly p zeros, whereas on the right half of the string we will have less than p zeros. Therefore, it cannot be the case that the left half of the string is the same as the right half of the string, which implies that uv to the 0, x, y to the 0, z is not in the language. And with this, we cover all possible cases, all possible scenarios based on vxy, because vxy cannot extend any further than any of these cases, since length of vxy should be less than or equal to p. And with this, since we have covered all possible cases, and in each case we have been able to show that there exists some integer I such that uv to the I, x, y to the I, z is not in the language, this implies that the given language L is not a context-free language.